Welcome back at it again with review video. Kind of your first review video of the year. I mean, you had a safety one, but come on, that wasn't, it was safety. This is the real big leagues, biomolecules. So let's get cracking. Let's go over the four major biomolecules first. Just talk about the function, talk about their structure, just kind of remind you of some things we talked about in class. Talk a little bit about enzymes, and then I'll end by just giving you a few sample test questions. So here we go. So remember, you got proteins, carbohydrates, lipids, and nucleic acids. We'll start with nucleic acids because that's the one we didn't talk just a ton about in class. So nucleic acids, remember, are your genetic information. So your DNA, your RNA, they're made out of a monomer called a nucleotide. Okay, so a nucleotide is what makes nucleic acid. And that's easy to remember because it kind of sounds like the same thing. So anyway, genetic information, they give you all your traits, DNA, RNA, that's nucleic acids. That's pretty much it. And the 40 question tests, there's not just a ton of nucleic acid, questions. Next up, protein. So protein, remember the building blocks of proteins. This is hugely important. Amino acids. Okay, so amino acids are the building blocks of proteins. Proteins are, as I said in class a few times, kind of the jack of all trades. The two main things we focused on were, we'll go three. So one, proteins build stuff. They build muscle, they build bone, they are great at structural support. Okay. Two, protein, remember enzymes, that special kind of protein. So proteins help to regulate cellular reactions and just all the different chemical reactions that go on in our body. Then the third thing, if somebody in your class today had the little card that said facilitated diffusion, okay, so proteins also are found in our cell membranes, and they help so just different substances go in and out of the cell. The main thing, though, for you guys is they help to build stuff and the enzyme idea. Other carbohydrates, and again, don't forget amino acids. That's really important. So proteins are made out of amino acids. How can proteins be different from each other? Well, if you flip the amino acids around, then they'd have different structure. So the order of those amino acids makes the protein specific. Okay, so if I had amino acid A, B, C, and D, I can make a totally different protein by going amino acid C, D, B, and A. Okay. Next, we'll go carbohydrates. So carbohydrates, the monomer, the building block of a carbohydrate, is a monosaccharide. Okay, so a monosaccharide, a single sugar molecule. What do they look like? Remember, that's the ring, okay, the ring pop. So the ring, and it has C's, H's, and O's. So it's a CHO, and it has ring. Back to the protein real quick, because I didn't talk about the structure. Remember, protein's the stick man, okay, Chan man. So protein's Chan, so it has carbon, hydrogen, oxygen, and nitrogen. And it's the stick man looking figure, okay? Nucleic acids, let me go back to their structure too, sorry. So nucleic acids, they're the only one that has phosphorus, so they're CHONP, C-H-O-N-P, CHONP, okay? Carbohydrates, back to them. Let's talk about their function. They are great at quick energy, all right? Now, if you watch Hank Green, which somebody in fourth period brought up, he talks about that they can store energy too. And they can, but remember, there's different types of carbohydrates. There's complex carbohydrates, like spaghetti or pastas of any kind or breads. They release the energy a little bit slower, okay? But for the main part, for your purposes on the test tomorrow, quick energy source, okay? Make sure you remember that, all right? Next one, we'll go with the last one, which is lipids, okay? So lipids, their main job, their main function, remember, they are great at storing energy. They're, gram for gram, they can hold the most energy. The other thing with lipids is the way they look. They're the E structure. So you have the glycerol backbone, okay, and then you have the fatty acids that kind of make up an E. And that E could be like that, or it could be like that, or it could be like that. It doesn't matter. It's still kind of that E structure. Okay. So graded energy storage, they have the E. They're a CHO, so CH and O, and then they look like an E. Trying to think other. Again, the monomer, that would be a fatty acid. So fatty acids are what build lipids. Okay. Then we spent a couple days talking about enzymes. Okay, so enzymes, remember, they're that special kind of protein. They're that special kind of protein that help to speed up chemical reactions. And there's a couple things that can affect an enzyme and how well it works. One, the temperature. The second big thing is the pH. So if the temperature is not right, that enzyme is not going to work very well. If it gets too cold, the enzyme might slow down. If it gets too hot, it actually can destroy or denature the active site. Bugs out here. Denature the active site, and then the enzyme won't work at all. Okay, so just keep in mind that word denature and kind of what that means. More about enzymes. Remember, they are like a lock and a key. So one enzyme can work over and over and over again, but it can only work on a specific reaction. Okay, enzymes cannot work on numerous reactions. They only work on a specific reaction. But they are like your key. You can open your house every single day. Okay, you don't have to get a new one. Just like an enzyme, you can use it over and over and over. The other special thing about enzymes is, and it's something, it's kind of common sense, but to think about, okay, is an enzyme going to work if there's no substrate there to act on? No. So if there's no substrate there, an enzyme's not going to work. It's not going to do anything. Okay. Gotta stay hydrated. All right. So I think that's about general information. My dogs are barking, but oh well. So let's look at a few questions. So I said in class several times, there's lots of graph questions when it's talking about enzymes. So if I show you on here, it's kind of weird. It's like a mirror. It won't really work, but I'll kind of walk you through one. So here is a perfect example. Okay. So if you see here, and again, you can kind of flip it, but there's the graph. On the y-axis, it says relative rate of enzyme activity. On the x-axis, it says temperature. And then the question is, the effective temperature on the relative rate of action of an enzyme is represented in the graph below. What's the optimum temperature for the action of this enzyme? So you'd find for this one, the highest point on the graph, find the temperature. So super easy. What does an enzyme do to the activation energy? Does it higher it, keep it the same, lower it? Good job, you're right, it lowers it, okay? So enzymes lower the activation energy needed to perform the reaction, okay? So if there's a graph about that, you want to find the graph that has the activation energy lowering after the enzyme worked on it. Not that there is a graph like that, but, maybe. You never know. Are enzymes really diverse and they can work on all kinds of reactions? No, they can't. Okay, remember, enzymes only work on one specific reaction. Lock and key. Your key only opens your house. Doesn't open your neighbor's house. More graphs about temperature. Okay. Here's like a little puzzle piece one. Pretty simple. Which substrate, which molecule is the enzyme going to work on? Well, the only one that's going to fit into the active site. That's a no-brainer. What else? More graphs. Few just general. Okay. Yeah, not bad. What is the enzyme release? We talked about this in class several times. Remember, it grabs onto the substrate, but when it's done, it releases the products. Oh, wait, my chicken's burning. Hang on, let's go over to the grill. Kind of the grill master. Don't burn, chicken. Ooh, chicken. Oh, let's bring this into real life. So, chicken. What biomolecule am I mainly going to be eating tonight for a delicious dinner? If you said protein, you're absolutely correct. So protein is what I'm going to mainly be having for delicious Strouch dinner. So there you go. Real world application. Boom. Here we go. This is the one you all want to see. Whoa. Pause it. Quick. Pause it. Just kidding. You didn't pause it. So anyway, this is the one with the structures. So remember, ring structure, carbohydrate, CHO with a ring, CHO with an E looking thing, lipid, okay? If it has phosphorus, automatic nucleic acid. Boom, done. And then stickman, okay, with an N for nitrogen, that's going to be your protein, okay? So there's 4 questions on that. If you break apart a I'm sorry. If you bring together 2 monosaccharides, what do you get? You did it in your model packet like at least 2 times. What did you get when you joined glucose plus fructose? You got a blank called sucrose. And that blank is a disaccharide. Remember, you join 2 things together. That prefix di means 2. If you break apart a protein, what do you have? What's the simplest form of a protein? Building blocks of a protein. Better know that. Hopefully you're thinking amino acid. Good job. What is starch going to do for a plant? Okay, starch functions as what? Well, this is that one. It's a little, again, carbohydrates, quick energy, but a starch like pasta, bread, they can store energy for those plants. Okay. Now, is it the best energy storing molecule? No, lipids are. Lipids are the best. How are lipids and carbohydrates dissimilar? So know some differences. Proteins and nucleic acids, how are those different? So look over your chart and see the differences there. Okay. Lipids and nucleic acids, you need to know the difference between that. And that's about it. Now, last question I'll ask you. So, our body, you can see I'm starting to sweat. It's a little warm out here still. So, our bodies, okay, they keep a temperature. They try and keep a temperature of about 98.6. That's where we like to be as far as an internal temperature. But do you think it stays 98.6 all day long, every day, no matter what you're doing? No. It's going to stay within a range, okay? So within a range of maybe 96 to 99.5 or 97 to 90, somewhere in that range is where your body's going to stay. So I know you might be asking yourself, what is he talking about? Well, there's one question about homeostasis that kind of leads a little bit into our next chapter and still does have to do, obviously, with biomolecules. But I just wanted to kind of give you a heads up since we didn't talk real specifically about that. So anyway, you guys have a great night. I'm going to be there in the morning. I'm here for you. I want you to do great. Think y'all in class, I'm seeing some good things. The activities we're doing, seems like y'all are learning what you're supposed to learn. Make sure you look over your stuff. If there's something you don't understand, come see me in the morning. Peace out. Live from Strouch Casa. Signing off.